Example 4.8. In this example, we're going to consider again the flow from the fire extinguisher. We are going to have the extensive property to be the mass and the intensive property to be 1, and we need to write the appropriate form of the Reynolds transfer theorem. Okay, so we're going to start with the standard way of writing the theorem. So it's the property of the system is equal to the rate of change in the control volume of the density B and the change in the volume plus the control surface rho B, the velocity, the normal vector dA. Okay, so we're going to replace the quantities that we know. We know that extensive property is going to be mass and the intensive property is going to be 1. So we replace this to be dm of the system, and this is going to be dt in the control volume rho dv plus the change in the control surface rho the velocity, the vector. So there are a couple of things that we notice. The extinguisher, once we open it, the function or the amount of mass in the control volume is going to change as a function of time. So this is a transient case. So we're not able to get rid of this part over here. So that one remains. Then notice that we have two control surfaces, that we have only one control surface. The control surface is the surface that allows the fluid to exit. Okay, and that's going outwards. Okay, so there is no outlet, however there is no inlet. Okay, so the way that we could write this, so we have mass of the system, okay, is going to be d dt, so we keep this, and this is in the control volume, okay, and then notice that we have an outlet, and so this is basically the integral of the outlet that is going to take place. So now we are able to identify whether we could take these terms out of this integral. For you to take any of these terms out of the integral, the quantities must be constant. So if we assume that the density doesn't change as it crosses the outlet, we could take it out. We assume the velocity to be constant as we leave out, and the area does not change as we go out. Therefore, this is simply going to transform as the density leaving, the velocity leaving, and the cross-sectional area leaving. And the rest remains the same. So for mass for this extinguisher, this is the Reynolds transfer theorem. So if you notice, basically what it means is that the change of the mass in the system basically indicates how much mass you have inside of the control volume, which is basically plus whatever you have leaving. So if you think about it, the total that you have in the extinguisher, which is what is inside and outside, is basically what you have inside, which is the first part inside of the control volume, plus what exited, which is the second term in this equation.